Hi, I'm Kiran, and welcome to The Hidden Why, where we explore the universe's strangest secrets. The mysteries of Venus. Why a day takes so long. Welcome to Venus, the planet we often call Earth's sister. They're about the same size, about the same mass. But that's where the family resemblance ends. This isn't our twin. This is our twisted sister planet, an alien world of extremes, where the normal rules of the solar system just don't seem to apply. Imagine a planet where the sun rises in the west and sets in the east. But that's not even the weirdest part. Imagine a single day stretching out for an incredible 2,800 hours. A day so long that a year on Venus is actually shorter than its day. How does that even work? What kind of bizarre forces could create such a scorching, toxic world? Today, we journey to this alien landscape to uncover how its crushing atmosphere and astronomical quirks make a day on Venus last what feels like a lifetime. Section 1. The Backwards Planet and its 2 days. The first puzzle you'll find on Venus is its spin. Almost every other planet in our solar system rotates counterclockwise as it orbits the Sun. But Venus does its own thing. It spins clockwise, a motion scientists call retrograde rotation. If you could actually stand on the surface, you'd watch the sun crawl backward across the sky, from west to east. It's a completely disorienting flip of our daily experience. This backward spin is also incredibly slow. It takes Venus a staggering 243 Earth days to complete just one rotation on its axis. That's what astronomers call its sidereal day. Now compare that to its year. Because it's so close to the sun, Venus zips around it in just 225 Earth days. And there it is, the heart of the paradox. A single spin of the planet takes longer than its entire trip around the sun. But that's not the whole story. The length of a day, as we think of it, is the time from one sunrise to the next. That's a solar day. On Venus, because its slow backward rotation is fighting its orbit, the solar day is actually shorter than its spin. The time from one sunrise to the next is about 117 Earth days. So, while a Venusian sidereal day is longer than its year, it gets about 2 sunrises and sunsets for every lap it takes around the sun. Still, a day of 117 Earth days means you'd get almost 2 straight months of dim, dreary daylight, followed by 2 straight months of absolute night. So why is Venus so slow? And why is it spinning the wrong way? The truth is, scientists don't have one single answer, but they have some killer theories. One leading idea suggests Venus had a violent past. Early in the solar system's history, space was basically a cosmic demolition derby. It's possible Venus got slammed by a huge planet-sized object. An impact so powerful, it didn't just tilt the planet, it flipped its spin entirely. Or at least slowed it down enough for other forces to take over. But an equally powerful culprit might be the one thing that truly defines Venus: its monstrous atmosphere. The Venusian atmosphere is about 93 times more massive than Earth's, creating a surface pressure that would crush you like you were a kilometer deep in our ocean. It's made almost entirely of carbon dioxide, with thick swirling clouds of sulfuric acid that have kicked off a runaway greenhouse effect. This toxic blanket traps heat so well that surface temperatures average a blistering 465 degrees Celsius, or 870 degrees Fahrenheit, hot enough to melt lead. That makes Venus the hottest planet in the solar system, even hotter than Mercury, which is right next door to the Sun. This thick, heavy atmosphere doesn't just sit there either. It's in constant, violent motion. And this is where we find another of Venus's great mysteries: atmospheric superrotation. While the planet itself rotates at a lazy walking pace, the upper atmosphere screams around the planet in just 4 Earth days, about 60 times faster than the ground below. We're talking about winds faster than the most powerful hurricanes on Earth. The atmosphere as an anchor. How can the wind move that much faster than the planet itself? Recent research suggests the answer lies in something called thermal tides. The same way our moon's gravity creates ocean tides, the sun's intense heat creates massive waves in Venus's thick atmosphere. The side of the planet facing the sun heats up, causing the air to expand and flow toward the cooler night side. This constant massive flow of gas acts like a giant engine, creating powerful global winds that fuel the super rotation. But this super-powered atmosphere does more than just create hellish weather. It actively works against the planet's spin. Think of it as a thick, heavy brake. As these ridiculously fast winds circle the globe, they drag against the planet's surface, creating friction. This enormous atmospheric drag is believed to put a powerful brake on Venus, slowing its spin and helping to lock it into its incredibly long day. In fact, the atmosphere's grip is so strong and chaotic that the length of a Venusian day isn't even constant. Radar observations have shown that the planet's rotation can speed up or slow down, changing the length of its day by as much as 20 minutes from one measurement to the next. These changes are likely caused by the shifting momentum of its sloshing, heavy atmosphere, a level of interaction between a planet and its air that's just unimaginable here on Earth. A day in the life of Venus. So, what would it actually be like to experience one of these marathon days? First off, you wouldn't see the sun. The permanent, thick clouds of sulfuric acid are so opaque that the surface is stuck in a gloomy, perpetual twilight. The sky isn't blue. It's a hazy, reddish-orange, because of the way sunlight scatters through all that carbon dioxide. The sun would be nothing more than a faint, blurry patch of light behind the oppressive clouds. The heat would be instant and unbearable. At 465 degrees C, it's a world where lead flows like water. The pressure would be even faster. At 92 times Earth's air pressure, you'd be crushed in an instant. And while those hurricane-force winds rage miles above, the air on the surface is so thick and dense that the winds are surprisingly slow, moving at just a few kilometers per hour. There is weather, but it's not our kind of weather. Sulfuric acid rain falls from the clouds, but it's so hot that the acid boils and turns back into gas long before it ever hits the ground, creating a rain that never falls. For nearly 59 Earth days, you'd be stuck in this dim, orange glow. Then, for another 59 Earth days, you'd be plunged into a starless, absolute darkness. All the while, the crushing pressure and searing heat would never, ever let up. It is a truly alien experience, defined by a steady, unchanging hostility. Sig. TA. The mysteries of Venus are a powerful reminder of just how wild and diverse planets can be. If you think these cosmic puzzles are as fascinating as we do, make sure to like this video and subscribe for more journeys into the strangest corners of our universe. From its backward spin to a day that outlasts its year, Venus challenges our idea of how a planet is supposed to work. We once imagined it as Earth's twin. But missions like the Soviet Venera landers and NASA's Magellan orbiter showed us it was a world forged in fire, a sibling that took a dramatically different path. Plenty of questions are still on the table. Was a giant impact the real cause of its backward spin? Or did a slow dance of gravitational forces and atmospheric drag flip it over billions of years? Could Venus have once had oceans before its own atmosphere turned on it? A new era of Venus exploration is just beginning, with NASA planning missions like Veritas, by Tidos and Da Vinci Plus, and the European Space Agency preparing its Envision orbiter. These future explorers will peel back more layers of our twisted sisters' secrets, mapping its surface in stunning new detail, and even dropping a probe right through its corrosive clouds. What they find won't just tell us about Venus. It will tell us about the forces that shape all planets, including our own. Venus remains a cosmic cautionary tale and an irresistible mystery just waiting to be solved.